Hi everyone, I'm Nick Villanueva. I am a DevRel engineer for Matter Labs, and today I'm going to be talking about Era Test Node. And what we're going to be covering today is what is Era Test Node, and I'm going to be walking through some of the features. What we wanted to do is build an in-memory node for zkSync development, both local testing and debugging. So we wanted this thing to start fast. It has the ability to fork a network at any given height, replay transactions that are on testnet or mainnet. We can have a pre-configured set of rich wallets whenever you start up the node, access to things like console log statements or the call stack, and more information about gas usage. So you can start debugging a little deeper into any transaction that is causing problems on testnet, or just more information in general. As we sort of talk about how does this work? Right now, if you want to get this running locally, you can go to our GitHub releases and download the binary. Once you download the binary, you just have era test node run in your command line, and the node should be up and running within under a second. There's also another option to get started faster. Instead of downloading the binary from the GitHub releases, you can do npx zkSync CLI dev start. That will take care of downloading the binary for you, and you can get it running locally that way. The final way is to use the npm plugin Matter Labs Hardhat zkSync node. And as long as you have this import statement at the top of your Hardhat config, you can start the node as part of, let's say, running your tests or doing deployments. So let's go into some examples and how we can use the Era test node. When it comes to deploying something like the greeter contract, one thing I kind of want to cover is the Hardhat config and what that looks like to point to the local node. When it's running, it is going to be running on port 8011. So in the Hardhat config, what that looks like is adding the in-memory network and setting the URL to be localhost port 8011. So let's take a look at what a brand new project can be used to point to the Era test node. You'll see in this brand new project that I created from the CLI tool, we have a few commands that is deploy, interact, and test. We'll be using those as we go through this demo today. The contracts that we're going to be focused on is that greeter contract that I talked about. It's pretty basic. You have a string that is being set in the constructor and two methods, one to get the string, one to set the string. So what we're going to do is call the deploy script. So in deploy, what we're doing is reaching out, gathering the greeter contract, and initializing the string to be hi there. So what we'll do in this command line up top is start running era test node. And you'll see in under a few milliseconds, we'll have an era test node running. And let's look at the output to the command line. The first thing you'll see is that the network is started on chain ID 260. And there are a list of 10 rich accounts with both their public address and their private key available for you to use for your local tests. And then finally, it tells you the node is running, localhost, port 8011. So it's up and running. It's ready to receive requests. And if we take a look at the Hardhat config that is being used in this template, there is a section in here for in-memory node. And this is the section that I referenced to earlier. You'll see it is pointed to port 8011, and zkSync is set to true. For deploying, we have a script in here called deploy.ts. So to call it with the network that I just mentioned is npm run deployed, and then we set the network to in-memory node. So as we run this, let's keep the era test node up in the upper console. And what you'll see is first we need to set the wallet private key. So in the .env file, you'll see that it's empty whenever you start a template. But as I showed you before, we have access to the private key. Go ahead and grab that, put that in here, and let's run it one more time. Now you should see in the output the full deployment of the greeter contract. So let's take a look at what got output to the console. This is the information about the transaction summary. So you can see who initiated the transaction, who paid for it, what was the gas being used, being refunded. There is a section in here for events if you want to dig in deeper, but in terms of what happened, you can see in the actual deployment contract, it outputs what the new contract public address is. So what we're going to do now is start using this other script called interact.ts. We're going to take the public address that the contract has been deployed to and use it as part of the script, where it's going to do three things. One, we're going to read what the current greet message is. You're going to update it to hello era test node. And then finally, we're going to read it one more time. So let's go ahead and run this. And while we're doing that, let's take a look at the output from the in-memory node. Cool, so it ran successfully, and in terms of the script, it sees that the message used to be hi there. It was updated in this transaction, and finally the new updated message is hello era test node, so it worked. Let's see what happened in terms of the in-memory node. First, you see the call that was made, and this is the call to get the original message of hi there. Then you have the transaction, and this transaction hash is what matches in the other scripts console. And finally, you'll see at the bottom another call to get the updated message. Perfect. Now, one thing you'll also see in the templates, we have tests. And so there is a test for this greeter contract. Let's go ahead and run this test. It's going to do the same thing that the interact script does of deploying the contract, setting it to hello world, updating it to hola mundo, and then validating that the update has worked and the new greeting has been set. And if we run this test, you'll see that all the tests pass. There we go, 9 had passed, but there was no update to era test node. And let's take a closer look as to why and what's happening. You'll notice that I didn't set the network. So inside of Hardhat, remember, we have this import statement at the very top that says use Hardhat zkSync node. And what that's going to do by default is use Hardhat as the network. And since we have zkSync true, what's happening is it is starting up its own in-memory node in the background and using that instead of an existing one. So this is a really useful tool when it comes to just being able to run your tests without needing to have era test node as a binary downloaded and sort of running in a separate terminal. You don't have to worry about that if you don't want to. But we'll get into why that might be useful a little bit later. So if we go back and sort of review what did we see, well, we started the era test node. We had the ability to deploy contracts, have rich accounts, use them. We executed a contract and ran some automated tests. Let's go into the next section of implementing new features or improved features for era test node when it comes to local development and debugging. So call stacks and console logs are very important when it comes to debugging, especially console logs is a great way inside of smart contracts so that you can see what's happening inside of the method as you are running your tests and get that feedback. Same thing with call stacks. You want to be able to see the full stack trace to better understand exactly what the problem was or what the state of your local node was that led to the point of having a revert or a panic or a halt. So let's take a look at that exact scenario. What we're going to do is go back to greeter, and inside of set greeting, I'm going to add a few lines here. I'm going to import Hardhat console, and I'm going to call console log at the beginning of set greeting. Now, while I compile these smart contracts, I'll talk about some of the other changes. Yes, I'm going to be console logging these two lines, set greeting called, and then the value that's passed in. But then I'm also going to have this require statement that checks that the string you're giving it is not the string test. If it is test, then I'm going to basically revert and throw the error that I've received a test value. So we've finished compiling down here, and let's go ahead and deploy this new smart contract. That's great. What we'll do is go to interact and use this new contract and set it again to hello era test node. So the difference now should be the console log statements. Let's see if we can find them. As we ran, right here in that middle transaction that was setting the new value, you can clearly see the console logs, set greeting called, and then the new string that it's being set to. So console logs are directly right here inside of your transactions. But then right underneath, you see there are 20 call traces. And these call traces aren't being shown by default. So it does give you the option to start or pass in a flag whenever you use your run command called show calls. However, we do have an API that's available at config set show calls. So what we're going to do is actually call this real quick, set it to all, go back, and let's run this one more time. You'll see that there's a lot more information. In fact, the call stack is fully here, and this call traces are all filled in. All 20 that were previously hidden now show up. They're properly indexed, tab indexed, and you can see all the way up until the exact moment where right here we are calling the two console log statements. We're using kcac to do that comparison to make sure that the string you passed in isn't equal to the value test. But if you look to the right, these hashes everywhere are not really easy to read. They're not human readable. And what we also added is an endpoint to resolve these hashes for you by reaching out to OpenChain. So we'll go ahead and set that and run this one more time. This is going to be a little slower than before. That's because it's reaching out to OpenChain for every one of these hashes to convert it to a human readable name. But what you'll see is on the right, most of these hashes have now been converted into something that you can understand. So yes, we are calling set greeting, and that is where the console log is coming from. That's where these two kcac statements are coming from. But also, everything leading up to the point where you are actually calling set greeting is also available to you. Everything from set transaction origin to the multiple chain ID requests that are coming in. And this gives you a better idea of where your gas costs are coming from. One more thing I wanted to cover is actually using that comparison for the test string. So let's update the interact script so that it's no longer just setting it to hello era test node, but it's setting it to that forbidden value of test. And what does a user see whenever this value is being set? What we can do is run this one more time. And right here, it shows you in bright red background with white font, execution reverted, we've received a test value. So anytime you have these reverts, it's very visible, very easy to see exactly where the problem is. Perfect. I showed you how Hardhat console log is supported with your test node. I showed you how to access the call stacks. I showed you that these ABI functions and even the events are now more readable because it's accessing OpenChain. You can easily spot errors and reverts as they show up bright red for end users. And let's talk about the next step of debugging a more realistic scenario. Era testnet has the ability to fork upstream networks. So that's mainnet, that's testnet, and once it's running a node in that state, we also have the ability to replay a transaction on top of that fork. So why would this be useful? Let's give a scenario of a user that reached out to us and they say, hey, we had some tests, everything worked fine, but zkSync has an issue where the transactions are failing with this error message. And they sent us this blurb of a function selector, not really too much information, but they did give us a link to the contract address. And they tested it out themselves. They're getting the same thing. And if you need any more information, please let us know. So what we did is basically took a look at the contract address. We pulled it up in Block Explorer, and we saw, yes, there are a bunch of sort of failed transactions. And in this first transaction, what we can do is copy what the transaction hash is. And if we go back to the Era test node, we can actually pass it in with a command called replay tx. And we give it the testnet as where we're forking upstream from, and then we give it the hash, the transaction hash that we want to replay. You'll notice that we are passing in this time the show calls and resolve hashes already from the beginning. We know we already want that information, so let's just go ahead and set up the node to run in that format. But we've also added something new, which is show gas details. I'll show you what that means, but the idea is to dig a little deeper into where the gas cost is coming from and what could be happening there. So if we go and run this command, so it forked already from testnet. It grabbed the batch of 2 transactions, and it's replaying them one at a time. It's also reaching out to OpenChain to get all of the human readable transactions, names for the transaction hashes, and then putting them in here. And what you'll see is in bright red, the set latest answer has an error panic. And if you scroll up some more, you'll start seeing a new section for this transaction. You'll notice at the very top, this transaction doesn't have a status of success anymore, it's failed. And more importantly, there is this gas details section. In here, it breaks down the gas costs. So you can see that 25% was spent on transaction setup, 64% on account validation, 9% on computations. If you go a little lower, the transaction setup actually broke down to be 93% of operator costs, and there's more information down below about overheads. This information sort of tells you where this gas cost is coming from, and it gives you more insight to debug what's actually happening, and you don't have to go back and forth and reach out to the end user about what they're seeing on their side. You have it available to you locally. The other nice thing is you'll notice the node is running. It's operating on port 8011. So even though you forked and you replayed the transaction and it failed, you still have the state of the local node available to you to continue messing around with. If you want to change some things or sort of test out some of the storage that's here or deploy another contract on top of this, the node is in such a state that you can do that and still interact with it. Another feature, and I mentioned this, is we can fork, right? We can fork testnet, we can fork mainnet, but we can also fork at a very specific block height. So you just say fork at, you give it the exact block number, and you're good to go. You fork exactly where you need to. We've talked about forking mainnet, forking testnet, forking at a very specific height. You can replay transactions on those forks, and you can investigate some of those gas details. So CI/CD integration. A lot of what we've shown is for local debugging, but we want to be able to give you the opportunity to integrate this with some of your workflows for CI/CD. In terms of GitHub, we have GitHub Action for the Era test node action that's available down here. All you have to do is add this action, and the node will automatically be running on port 8011. So if you need it for any of your local tests, you just have it available, and it should be really easy to set up, just 2 lines. If you wanted to, for example, add it to the Hardhat, you don't have to add anything special. I kind of reviewed that already. You just, do Hardhat tests, and as long as you have that npm plugin, everything should work. Let's wrap this up and talk about what's next for the project and sort of where we're heading. Well, one, we want to have this entire repo be embedded with the open source community. We built it from the beginning to be, publicly open source. All issues are up there. Anyone can contribute. We accept pull requests from forks, and feel free to take a look and contribute yourself. Make issues if you see any problems. We also want to continue supporting more APIs. This thing is still growing. Not every API is implemented, but the majority are. And if there's anything missing, feel free to contribute and add it yourself. The possibilities are sort of endless when it comes to a product like this. We want to, at the end of the day, make it easier for any developer to use zkSync. So if that's providing more information about gas details, if it's giving you a tool to help you figure out the frustrations that you're running into deploying to testnet, whatever the case may be, there's probably a way to do that with a tool like this. And if you have any feedback or questions, please, like I said, reach out over GitHub discussions or the GitHub issues for the Era testnet repo. All right, thank you very much.